bonus coverage. Hopefully you have watched the video about solving a differential equation. I wanted to, because I'm actually going to solve the logistic differential equation for the function p, right? So that function p that we don't need really to answer a lot of logistic growth curve function problems. I'm actually going to work through how to actually get that function just in case you're curious. So this is where the partial fraction decomposition is going to come into play. So we're going to separate the variables, all right? So divide by p, divide by the quantity k minus p, multiply by dt. So we've got those things ready to integrate. So we integrate, all right? So while we integrate that, we need partial fraction decomposition because we have a factor denominator. We need to figure out what that is, partial fraction decomposition wise. So let's do that. So we'll take a little time out for partial fraction decomposition. We need to turn 1 over p times k minus p into its component parts, a over p plus b over k minus p. You're probably thinking, I don't see any numbers. Well, you're wrong because there's a 1 in there. All right, so we're going to recombine them back together. Multiply by k minus p, multiply by p, booyah, there you go right there. So we'll pick some smart values for p, right, because that's the variable in question here, dp. We're integrating with respect to p. So we'll let p equal k. That's going to eliminate a. So b times k is 1. All right, b is 1 over k. Got it. If we let p equal 0, that's going to eliminate the b. So we have negative, we got k times a is equal to 1. Therefore, a is equal to 1 over k. So really what we've done is we've turned the integral dp over p times the quantity k minus p into, I've factored out the 1 over k, 1 over p plus 1 over k minus p. So the integral of 1 over p, hey, that's the natural log of the absolute value of p. The antiderivative of 1 over k minus p is, careful, negative natural log of the absolute value of k minus p, because the slope of the denominator is -1. Watch out for that. All right, so here we are. We're at 1 over k times the natural log of p minus the natural log of the absolute value of k minus p, and then the integral of a with respect to t. Well, that was piece k. That's at plus the mystery constant. So we're going to solve this generally now. So we're going to multiply both sides by k, and then kind of condense the natural log. So you see that happening here. I've multiplied by k. So k, cap k, at plus k times c is still c. And then condense the natural logs. Then I'm going to exponentiate. So I exponentiate e to the natural log of critter is just the critter. And then is equal to c e to the cat. All right, still going. Remember, we're going to solve for p. So we drop the absolute value bars. Drop them like they hot. But that means plus or minus ce to the cat. But plus or minus c is just c. It's an unknown constant. All right, then we're going to flipsy daisy. We're going to flipsy daisy everything. And when you flipsy daisy everything, 1 over a constant is a constant. And when you flip e to the denominator, you get e to the negative cat. All right, here's the reason I did that is because now I have k minus p divided by p. Well, I can split that up. I can say k over p minus 1 is equal to that. Get ready, here it comes. We're going to add 1 to get k over p is equal to 1 plus c cat. And then we're going to flip it again. So p over k is 1 over 1 plus c e to the negative cat. All we got to do is multiply by k and bing, bang, boom. That was fun. How easy was that? That was so easy and enjoyable. Let's do that again.